Hello everyone. In this video, we're going to use the tactical switches to control the LED. And the one switch over here is the pull up switch and the other over here would be pull down switch. Well, from this video on, we're going to use the code generator in STM32Cube IDE, just so you know. And I'm going to explain about the pull up and pull down configuration real quick, just in case. And so if you take a look at this pull up configuration first, just imagine the situation we're not pressing the button over here. Then the port B1 and 3.3 voltage are facing each other with a pull up register over here, but still PB1 would be a high state because of this 3.3 voltage. But once we press the button over here, the PB1 is right connected to the ground, so it will be low state when we press the switch. But on the other hand, well, the pull down switch is the totally opposite structure from the pull up configuration. So if you're not pressing the pull down switch over here, then PB2 and ground are facing each other with a pull down register over here, but still PB2 would be low state, as you can see. But once we press the pull down switch over here, then PB2 will be right connected to the 3.3 voltage, so it will be the high state in this case. So if you want to follow this demonstration tutorial, then you guys have to follow this instruction and configure this circuit, as you can see. Well, let's move on to the pinout configuration. So I'm gonna throw in the GPIO output for PA1 and PA2 for LEDs, and PB1 and PB2 would be GPIO input because we're going to use these pins for switches. And I'm gonna, turn off the LED at first. So I have to set up the low for the output level for initialization. And it's gonna be the output push pull, no pull up and no pull down for the output. And it doesn't matter what the low maximum output speed. And this LED would be pull up LED. And in this case as well, it would be just pull down LED. And when it comes to PB1, it will be a pull down switch. It will be pull up switch. Since we are going to use the external pull up and pull down circuit configuration, as you can see, so we're not going to use the pull up or pull down structure inside of the MCU. And so this is it. And in this case, we're going to throw in pull down switch as well. So after that, well, still we're going to use the clock configuration with the high-speed internal clock, which is 8 megahertz. So I'm not gonna set up this part. And well, when it comes to debug mode, I'm just gonna use the serial wire debug mode. So this is it, and let's just generate the code. Well, the code is generated, as you can. Well, if you take a look at this header file, there is the predefined macro, so I'm gonna copy and paste for the convenience of coding. And if you take a look at this Holo driver file, we're going to use the read pin function for the switch for reading the state of the switch, and we're going to use the write pin function for controlling the LED. And lastly, if you go into this part, we're going to use this macro as well. Well, the reset macro stands for 0 and GPIO pin set stands for 1 in this case. Well, I just throw in some code to save the time. So this is the first name, and from this part to line 99, well, I just throw in some structure of this code to save the time, just so you know. Well, before we jump into the code, we need to understand what the debouncing technique is. And this is the perfect representation of debouncing structure. So, well, when a mechanical switch like tactical switch is pressed, the signal does not change clearly. Instead, it bounces for a short time, causing multiple unwanted transitions. And so this is called switch bouncing. And without proper handling, a single press may be detected multiple times. And so instead of using a delay function which blocks the CPU, we can implement softer debouncing by using the current state over here and the previous state of the switch over here. And so in each loop, as you can see, we read the current input value and compare it with the previous one over here. And so if the two states are the same, well, then the signal is considered stable. Otherwise, we treat it as a potential transition and update the previous state like this. And so we're going to do the same thing in the step 2, as you can see with the pull down switch as well. So a button press or release is accepted only when the new state remains consistent, effectively filtering out bouncing without any delay. So this approach is non-blocking, efficient, and well-suited for real-time embedded systems. Well, let's move on to the coding part. Well, first things first, we need to define the state of the pull-up switch and pull-down switch. So as I already told you, the pull-up switch is the high state, and the pull-down switch would be low state. So just throw in this macro like this. And now we're going to read the value of the switches. So as I already told you, we're going to use this function, copy and paste it. And so when it comes to pull up switch, the port macro would be GPIOP. So we're going to use this macro instead. So this parameter would be switch port, pull up switch port, and the pin would be this one. Just copy and paste it. There we go. And when it comes to pull down switch, over here, we're going to throw in this parameter and we're going to use this parameter as well. There we go. So we read the value of the switch in this case. Now let's move on to step 1, which is related to pull-up switch. So when it comes to pull-up switch, when it is pressed, then the port would be right connected to the ground. So you need to check whether the switch is pressed or released. So if the pull-up switch is pressed like this, then we need to turn on the LED. We're going to use this function. So in this case, we're going to turn on the PA1, as you can see. And to turn on the LED, we have to throw in the GPIO pin set in this case. There we go. And to turn off the LED, we're going to use the reset macro in this case. And finally, we need to update the state of the pull-up switch. So PU previous is PU now. There we go. And now let's move on to step 2, which is related to pull down switch. But just so you know, if you take a look at this entire structure, the structure itself is exactly same, but the variables that we use or the macros are slightly different. And so when it comes to pull down switch, when this switch is pressed, then the port is right connected to the 3.3 voltage. So we're going to throw in the GPIO pin set in this case. And we need to turn on the LED in this case as well. So we're going to use this function. But like I said, the port is a little bit different, but because we're going to use the different pin, PA2, for the pull down switch. We need to turn on the LED when we press the switch. And otherwise, we need to turn off the LED. So I'm going to throw in reset in this case. There we go. And so finally, we need to update the state of pull down switch in this case as well. So it's going to be pull down, pull down. There we go. So I just complete all the code. So when I build this project, well, build is completed without any other errors. Well, I just unloaded the code right now. So left switch over here uses pull up, and the right switch over here uses pull down. Well, debouncing is implemented, so the LED turns on only on the first valid press. Well, it looks like everything is working as expected. So this is all about today's tutorial, and I hope you find it very useful through this video. And so thanks for watching, and see you on my next video. Bye guys.